Comment 1731 is about a very powerful thinking device in maths, which is to check your thinking on a concrete example, and I recommend you use this whenever you're not sure that the path you're about to take is the correct one. So, for example, let's say you had a total mind blank and you couldn't remember how to expand that, and you're tempted to think that you just square this and then square that. Well, just test out if that works. If it was 3 plus 4, that's plainly 7 squared, which is 49. If you can just square this to get that and square that to get that, then you can also do it on this concrete example, which is 25. So no, you've decided you can't because 49 is not equal to 25. So that's what I mean by testing your thinking out on a simple concrete example of your own invention. Now, I don't recommend using zeros or ones because they have special properties. 1 is the number which, when you times it by something, it doesn't make any difference. 0 is even more special. If you add it to something, it doesn't make any difference. And if you times it by something, then it always creates an answer of 0. Even more special is that it can screw things up in a way that not many other numbers can. So, for example, 1 divided by 0 equals math error. So unless you are trying to mess something up because the question tells you to prove that something doesn't work, when you're making up your own little examples, don't use zeros or ones. Even the number 2 I try to avoid because that's special as well. But let's look at another example. Let's say you, just another simple example from GCSE. Let's say you are you're doing some thing whereby you're working out the number of years that something's been in the bank, and the question also mentions the number of withdrawals, and then there's some amount of money or whatever, and the amount of money is I don't know, £100, £200, £300, £400, and you need to come up with a rule for the amount of money in terms of the number of withdrawals or whatever, and you have a hunch that it's money equals 100 times or times withdrawals. So the money equals 100 times the number of withdrawals minus 1. We'll just test out if it works. So I have a concrete case here of 200. So is 200 equal to 100 times the number of withdrawals minus 1? Yes, it is. So therefore, you can be a little bit more sure that you have correctly written down an algebra rule. So I'll just remind you where this all came from. I was simply saying that if you have some thinking going on in your head and you're not sure whether you can rely on it, just to test it out on a simple example, either one that you've invented or one that's actually physically in front of you because you've written down an early term from a sequence. My example there didn't really make a huge amount of sense because I made it up on the spot. I'll just give you an even more simple example from the GCSE. When you have a sequence like this, then you notice that there's a gap of 3. So maybe that's your guess. Then just test it out. So that's supposed to stand for a position. So let's test it out on the 4th example. 3 times 4 is 12. It's not supposed to be 12. It's supposed to be 11. So just adjust the rule. And so what I've done is I've just tested it out using an example that's actually in front of me. The fourth is an 11. So therefore, when I put a 4 where n is, I should get 11. I don't get 11, I get 12. So I just adjust by subtracting 1.